Now let's look at the methodology behind the project. We will show how the team measured real-world 5G network coverage and performance in drone corridors, and how this approach helps ensure safe UAV operations. Just as people are not birds and do not fly, mobile coverage at the ground level is not the same as in the air. And ground level coverage is not the same as airspace coverage. The network coverage simulation tools are primarily designed to calculate standard mobile network coverage at ground level, not at flight altitude. This is one of the main reasons why it is important to make practical measurements. In addition, other conditions, obstacles, densely populated areas, need to be taken into account when flying unmanned. The UAV-based measurements give an accurate assessment of the network coverage and the performance in the defined UAV airspace, anticipating all risks related to flight safety. The 5G signal at different altitudes can be evaluated in two ways. First, theoretical signal coverage. It requires involvement of the mobile operator to obtain base station parameters, that is, transmitter power, antenna gain, antenna tilt angle, etc. A substantial amount of initial work is needed to process the collected information. And second, practical measurements. This approach involves much simpler preliminary work without the need for operator involvement, preparing the drone for flight, setting up the measurement equipment. During the flight, it is possible to flexibly adjust the altitude, distance, and direction for more precise signal analysis. Practical drone-based measurements are more accurate and reflect the actual 5G signal coverage. Practical measurements can be performed anywhere without the need for prior data processing or mathematical calculations. They reflect the actual signal coverage in a specific location and at specific time. During the practical measurements, both signal coverage and performance were evaluated. Two testing methods were used: passive and active. The passive method allows for the assessment of precise physical parameters of the signal, providing insight into signal coverage. The active method enables evaluation of the signal's performance, such as download speed, upload speed, latency, jitter, packet loss rate, etc., at a specific location and time. A draft CPT-ECC methodology was developed in the 5G for Lives project to assess 5G new radio network coverage and performance for drone operations in airspace corridors. To provide practical technical guidance, a European-level CPT-ECC report is proposed. This report will define how to evaluate mobile networks if 5G networks are ready to support UAVs, focusing on the key indicators like signal strength, that is RSRP, signal quality, SINR, latency, and data throughput. It will help ensure safe and reliable UAV integration across Europe by addressing technical, regulatory, and operational aspects. In the end, this will make it easier to safely use drones across Europe with the help of mobile networks.